Hello everyone. Today we are going to talk about one of the most common 3D printing used extensively, which is Fused Deposition Modeling, or FDM. Ever wonder how those wild 3D printed gadgets go from digital dream to real touchable thing? Let's break down Fused Deposition Modeling, the superstar behind a ton of 3D printing magic. So, imagine a super precise hot glue gun with a robot's brain. First, you design a 3D model. Could be a phone stand, a toy dinosaur, or even a custom wrench. The printer's software slices that model into hundreds, sometimes thousands of thin layers. Now here's where the action starts. The FDM printer feeds in a filament, think long spool, but made of plastic. PLA, ABS, PETG, TPU. The filament gets pushed into a heated nozzle, melting it just enough so it can flow out, but not so much that it turns into a puddle. The print head moves around, laying down melted filament one tiny line at a time, following the sliced blueprint. As it finishes a layer, the printer either moves the print bed down or raises the nozzle up, setting the stage for the next layer. The melted plastic cools and hardens almost instantly, fusing with the layer below. This stack and cool process keeps going layer by layer until, ta-da! You've got a solid 3D object built up from nothing but a plastic spool. FDM isn't just for hobbyists printing models in their garages. It's a game changer for prototyping. Engineers can whip up new parts fast and cheap. In medicine, custom splints and prosthetics can be printed to fit a patient perfectly. Aerospace, lightweight complex parts. Automotive, prototypes and specialized components. And hey, if you're into eco-friendly tech, there are even filaments made from recycled plastics or wood fibers. That means you can experiment and tinker with new materials, all with the same printer. Pretty cool, right? If you enjoyed this dive into FDM, hit that like button and subscribe for more awesome tech breakdowns. Catch you next time.